So hello people and welcome back. In this session we will be doing all the trigonometry and heights and distances questions that have turned up from the year 2022 to 2025 in the board exams. Let us directly begin, and here we have the first question, which says prove that cot a plus tan a minus 1 times sin a plus cos a, all of that divided by sin cube a plus cos cube a, and that should be equal to sec a times cosec a. Now where do we start this thing from? We start this thing from LHS for obvious reasons, because it is a bigger thing, and we can see the denominator is factorizable. Okay, so I know the identity which says a cube plus b cube is equal to a plus b times a square minus ab plus b square. So over here sin cube plus cos cube can be written as sin plus cos times all of that. Okay, so let us start with the LHS, that is cot a can be written as cos a over sin a, plus the tan a can be written as sin a over cos a minus 1 times the entire sin a plus cos a, and I will divide all of that by sin cube plus cos cube, which is sin a plus cos a, times sin square a minus sin a cos a plus a cos square a. Okay, so over here I can very clearly see that sin a plus cos a and sin a plus cos a can just be cancelled out, and I can just take LCMs in the numerator. So this becomes cos square a plus sin square a minus, this thing can be written as sin a times cos a, and then all of that gets divided by sin a cos a, and in the denominator I will be left with sin square a plus cos square a, which adds up to 1 because we know sin square theta plus cos square theta is 1. So that becomes 1 minus sin a times cos a. Over here I can again see that in the numerator I have cos square a plus sin square a, which again adds up to become a 1. So I'll be left with 1 minus sin a times cos a upon sin a cos a, and then the other denominator also gets fixed with the denominator over here, so which is 1 minus sin a times cos a. I can get rid of the two things, 1 minus sin a cos a and 1 minus sin a cos a, and over here I am left with 1 upon sin a times cos a. Now this thing can just be flipped and written as 1 upon cos is definitely a sec, so this thing can be written as sec a, and 1 upon sin is cosec a, so that is the cosec a that we have, and that is the answer. Okay, that was a very easy question for a 4 marker, but yeah, that's good. Let's move ahead. The next question that we have over here, okay, that is a question from heights and distances, and let's see what does it say. It says in the given diagram AB is a vertical tower 100 meter away from the foot of a 30-storied building CD. Okay, so here we have a vertical tower AB which is 100 meter away from a 30-storied building. So CD is a 30-storied building. Okay, that's fair. And then it says the angles of depression of point C, from point C and E. Okay, from point C and E, the angles of depression. Angle of depression is when you look down from a horizontal line. Fair enough. So it is 35 degree and 14 degree. Perfect. Nice. And then it says E being the midpoint of CD. Okay, so E is the midpoint of CD, which means CE and ED, these two distances would be equal. Fair enough. Okay, what else do we have over here? It says use mathematical table for the required values. Okay, fair enough, and that has to be up to 2 decimal places. Fine. And find the height of tower AB and the building CD. Okay, we need these two things. Okay, let us try to figure out a few things over here. I can see a few triangles, a few right angle triangles, but I would prefer naming a few things. So let's say AB is X. So if AB is X, then PD, which is exactly opposite to AB, which will also be equal to X. Now, can I name this EP as Y? Absolutely. This thing is Y. Okay, fair enough. Another thing, if BD over here, this distance is 100, then definitely AP would also be 100 meter. Okay, now the question says that E being the midpoint of CD. So if E is the midpoint of CD, then definitely if this thing is x plus y, this thing would also be equal to x plus y. Okay, now these are the things that I have in the diagram, and with this much of information I can just move ahead and try to figure out what trigonometric ratios can be applied over here. Okay, so let us come back to this thing. So this is x over here, this is x, this is y, and we said that this is x plus y, and this was 100. Now we can see that there are two triangles that are really important to us, which is this triangle AEP and there is this triangle ACP. So these are the two important triangles for us. In both these triangles we can see that the hypotenuse is not required, so which means the opposite and adjacents are required, which means we'll be dealing with tan theta obviously. Okay, so let's say tan theta is opposite over adjacent. Now in the smaller triangle, which is triangle AEP, okay, so in triangle AEP I can say tan of 14 degree. Now how is tan of 14 degree over there? So obviously if this line and this line, these two lines are parallel to each other, then definitely this angle has to be 14 degree because of alternate interior angles, and similarly the other angle will also be 35 degree. Fair enough. So tan 14 would be equal to y, which is the opposite, over 100, which is the adjacent. Okay, and I don't know what tan 14 is, so I can definitely use mathematical tables, or right now I'm using a calculator to figure it out. You people have to use the tables. So tan 14 is 0.2493. I need to round it off to two decimal places, so I can say it is actually 0.25 is equal to y over 100. So when the 100 goes there, it becomes y is equal to 25 meters. Fair enough, I got the value of y. Now let us move ahead to the next triangle, which is triangle ACP. So in triangle ACP, tan of 35 degree. How did I get a tan 35? Because this line and this line, these two lines are parallel to each other. So if this is 35, this has to be equal to 35 alternate interior angles. Okay, so tan 35 is equal to opposite. The opposite of this thing is this entire thing, which is x plus y and another y. So x plus y and another y basically adds up to x plus 2y. So that is x plus 2y, all of that divided by 100. So we have 100 over there. Now let us figure out what tan 35 is. Tan 35 I suppose is 0.700. Okay, so 0.70 is equal to x plus 2y, all of that divided by 100. Now this 100 goes to the other side, gets multiplied with 0.7 and it becomes a 70 is equal to x plus 2. Now I definitely know the value of y, which is 25. So let us plug in 25 over there. So 70 is equal to x plus 50, and hence I get the value of x to be equal to 20 meter. Okay, now the question says find the height of tower AB. So I can write therefore AB, which was equal to x, that is 20 meter, and the height of the building CD. Now how much is the height of the building CD? It is all of this thing. Okay, so all of this thing is basically x plus y and another x plus y. So I'll write CD is equal to x plus y, all of that times 2. That would be equal to 20 plus 25 times 2, which is 45 times 2, and that, my friends, is equal to 90 meters. Very easy question. Okay, let us move ahead to the next question. This question says statement 1, which is sin square theta plus cos square theta is 1. Yes, absolutely, that is a correct statement. Statement 2, cosec square theta plus cot square theta is 1. No, that's not true. We need to have a negative sign over there. Okay, we know that cosec square theta minus cot square theta is 1. So this statement is wrong. So I can just mark only 1 and move ahead. That's a very easy MCQ. You don't need more than 10 seconds to even write the answer. Okay, next question. The next question says factorize sin cube theta plus cos cube theta, hence prove the following identity. Okay, factorizing, again kind of a repeated question. We know that this is a cube plus b cube, so I can say a cube plus b cube is equal to a plus b times a square minus ab plus b square. Therefore sin cube theta plus cos cube theta can be written as sin theta plus cos theta times sine square theta minus sine theta cos theta plus a cos square theta. Now again, we definitely know that sine square theta and cos square theta adds up to 1. So this thing can be written as sine theta plus cos theta times 1 minus sine theta into cos theta. Okay, that is factorized, and that is the value of sine cube theta plus cos cube theta. Very easy. Okay. Next, it says prove the following identity. Okay, I'll prove it. We need to start with the left hand side, obviously. So it is sine cube theta plus cos cube theta, the whole thing upon sine theta plus cos theta plus sine theta times cos theta. Okay, now I know that the numerator is sine cube theta plus cos cube theta, which I just factored out to be equal to sine theta plus cos theta and all of those things. Okay, so I can just replace it with that. So it becomes sine theta plus cos theta times 1 minus sine theta into cos theta, and the denominator is just sine theta plus cos theta. It remains as it is, and I have a plus sine theta times cos theta over here. Now I can get rid of sine theta plus cos theta from the numerator and the denominator. So this goes away and this goes away. And what am I left with? I'm left with 1 minus sine theta times cos theta plus sine theta cos theta. We can now cancel out minus sine theta cos theta and plus sine theta cos theta, and finally the answer is equal to 1, which is what was required. Very easy. Next question. So the next question says the angle of elevation of the top of a 100-meter high tree from 2 points A and B on the opposite sides of a tree are 52 degree and 45 degree. Okay, so this DC is a tree. The diagram is given to us. It is 100 meter and 2 points are A and B, and the angle of elevations are 52 degree and 45 degree respectively. Fair enough. Find the distance AB to the nearest meter. Okay, that's good. So we basically need to figure out the distance AB, which is this entire distance. I will split this distance up into two parts. So let's say AC is X and let's say CB is equal to Y. Now in these two triangles we can see that we have a triangle which deals with opposite and adjacent. So we definitely need to use tan theta. So I can say tan theta is opposite over adjacent. Now let us start with triangle ACD. In triangle ACD, I can say tan 52 is equal to, opposite of 52 is 100 over here, over X, which is the adjacent. Okay, let's figure out what tan 52 is. So tan 52 is equal to 1.2799, so we can say it is 1.28. So 1.28 is equal to 100 upon X. Send the X to the other side and send the 1.28 down over here. So X is equal to 100 upon 1.28. Let us figure out how much that is. 100 upon 1.28 is 78.125. So X is equal to 78.125 meters. Those many meters. Fair enough. Let us pick up the other triangle, and it is triangle DCB. Okay, in triangle DCB, I can say tan of 45 degree is equal to opposite. 45 opposite is 100. So 100 over adjacent, which is the Y thing. Okay, now we all know tan 45 is 1. So I just write 1 is equal to 100 over Y. Y goes to the other side and Y is equal to 100 meters. Okay, what do we need? We need the distance AB. Okay, we can say that AB is actually equal to X plus Y, which would be 78.125 plus 100, which is 178.125. But the question says we have to round it off to the nearest meter. So I can get rid of the decimal and I can say AB is equal to 178 meters. So easy for a 5 marker, really easy. Okay, let us move ahead to the next question. It says 1 plus sine A times 1 minus sine A is equal to what? Okay, we know that this is factorizable, like it is factorized form. It is difference of squares. So I can write it as 1a plus b into a minus b is a square minus b square. So it would be 1 square minus sine square a, which is 1 minus sine square a is cos square a. So if it is cos square a, then option D is the correct option. Very easy, 10 seconds. Next question. It says prove the following identity. Okay, let us start. What do I do? What do I do? I can see that this sine square theta minus 1 is kind of problematic. So I can pull out a minus sign from there and write it as 1 minus sine square theta. And we know there is an identity which says sec square theta is 1 plus tan square theta. So instead of this tan square theta plus 1, I can write sec square theta plus a 1 remains as it is. Now 1 minus sine square theta is cos square theta. So this is minus cos square theta times sec square theta can be written as 1 upon cos square theta plus a 1. I can cancel out cos square theta and cos square theta. I'm left with minus 1 plus 1, and that should be equal to 0. So easy, very easy. Next question. This question reads, from the top of a tower 100 meter high, a man observes the angle of depression of two ships A and B on the opposite sides of the tower as 45 degree and 38 degree. Fair enough. The man is standing over here. That is the horizontal line, and he observes it that it is down on the other, like on two opposite sides, the two ships, which is 45 degree and 38 degree. Angles of depressions are given. If this is 45 degree, then alternate interior angles, this is also 45 degree. And if that is 38, this also has to be 38. Fair. It says if the foot of the tower and the ships are in the same horizontal line. Okay, foot of the tower and the ships are in the same horizontal line. That's easy. Okay. It says find the distance between the two ships A and B to the nearest meter and use mathematical tables. Okay. Now, can I just say this AC is X and this CB is Y? Okay. We can see there are two triangles, and these two triangles are dealing with opposite and adjacents. We need to use tan theta. Let's start. So I know tan theta is opposite over adjacent. Let us start with the left triangle, which is triangle ACD. So in triangle ACD, I can say that tan of 45 degree is equal to opposite, which is 100, over adjacent, which is X. So it is 100 over X. Tan 45 is 1, and that would be equal to 100 over X. Therefore, X is equal to 100 meters. Easy. Next, let us look at the right side triangle, which is triangle DCB or BCD. In triangle BCD, here we may say tan of 38 degree is equal to opposite, which is 100, over adjacent, which is Y. So that would be 100 over Y. Let us see how much tan 38 is. So tan 38 is 0.78. So let 0.781, which was a closer value, over Y. Okay. Y goes to the other side. 0.781 comes down. So 100 over 0.781. Let us divide that thing. 100 divided by 0.781. And that is equal to 128.04, but I am going to consider it to be 128 because it says up to the nearest meter. Okay. So Y is equal to 128 meter. So if Y is 128 and X is 100, we can now say that the distance AB is actually equal to X plus Y, and that is equal to 100 plus 128, which is equal to 228 meters. Very easy. Nice. Let's move ahead to the next question. Okay. So this question says a lighthouse is 80 meter high. The angle of elevation of its top from a point 80 meter away from its foot along the same horizontal line is very easy, 45 degree. I'll tell you how. Let us draw a diagram. So this lighthouse is 80 meter high, and we are at a point which is also 80 meter away from it. So if this is 80 meter and we are at a point which is also 80 meters, so this is us, okay, A, that's me, and this is, let's say, B, and this is C. This BC is the tower and A is me. This is obviously a right angle. It says the angle of elevation, which means I need to figure out how much this angle over here would be. Now obviously this is an isosceles triangle, So if this and this is equal, obviously the two angles have to be equal. So sum of all angles is 180, one of them is 90, which means the other two have to take 90 equally. That's 45 and 45. It's an isosceles triangle. Next question. So this says, prove that 1 upon 1 plus sine theta plus 1 upon 1 minus sine theta is equal to 2 sec square theta. Okay, let us start with the left hand side. So the LHS says 1 upon 1 plus sine theta plus 1 upon 1 minus sine theta. Let us just cross multiply these things. So it becomes 1 minus sine theta plus 1 plus sine theta. All of that, these two denominators just get multiplied. So 1 plus sine theta times 1 minus sine theta. From the numerator, I can get rid of negative sine theta and positive sine theta, and I am now left with 1 plus 1, that is a 2. And in the denominator, it is a plus b times a minus b, difference of squares. A plus b times a minus b is a square minus b square. So it would be 1 minus sine square theta. Now 1 minus sine square theta is cos square theta. So I can write this thing as 2 over cos square theta. Now 1 upon cos is sec. So 2 over cos square theta can be written as 2 sec square theta. Very easy question, and it is only for 2 marks. So yeah, fair enough. Next question. This thing says two lampposts AB and CD, each of height 100 meter, are on either sides of the road. P is a point on the road between two lampposts. Okay, the diagram, I think the diagram was given in this question, I can't just recall, but yeah, even if the diagram is not given, we can probably draw the diagram. So that is the lamppost, that is another lamppost over here. Okay, let us name them AB. This is AB and this is CD. Okay, just connect the bases, and it says that the angles of elevation of the top of the lamppost from point P are 60 degree and 30 degree. Find the distances such and such. Okay, so I just say that this is a point over here which is P, and I just connect it over here. So this is point P. So the angles are given to me as 60 degree and 30 degree, and the lampposts are both 100 meter high. What do I need to find? I need to figure out the distance PB, which is this one, and PD, which is this one. Okay, very easy. I can see I have two triangles over here, and both the triangles right now are dealing with opposites and adjacents. So I have to use tan theta. So let's say tan theta is opposite over adjacent. We can start with triangle ABP. So in triangle ABP, tan of 30, tan 30 is opposite, which is 100, upon the adjacent, which is this thing, which is PB. Tan 30 is 1 over root 3. So I can write 1 over root 3 is equal to 100 over PB. The PB goes to the numerator and root 3 also goes to the numerator on the other side. So PB is equal to 100 root 3 meters. You definitely can stop over here, or you can say it is equal to 100 times 1.732. So that is equal to 173.2 meters. That is also fair. Even this is fair enough. Okay, now let us come to the next triangle, which is triangle CDP. In triangle CDP, I can say tan 60 is equal to opposite, which is 100, over adjacent, which is PD. So 100 over PD. Tan 60 is root 3, which is equal to 100 over PD. The PD goes to the numerator, root 3 comes to the denominator. So PD is equal to 100 over root 3, those many meters. Or you can divide 100 by 1.73 and write your answer, 1.732. Let me just check how much that is. And that is equal to 57 point something. It is 57.73. Okay, so 100 over 1.732 is 57.73 meters. Okay, you can definitely leave it over here also, but rationalize the denominator, that would be better. That's an easy question, no tables, nothing, very easy. Okay, let us move ahead to the next question, which is this one. Prove that this equals to that. Okay, very easy. Let us start with the left hand side. So the LHS is 1 plus sine theta all squared plus 1 minus sine theta all squared, all of that divided by 2 cos square theta. We know the identity a plus b the whole square and a minus b the whole square. We need to apply those identities in the numerator. So it is a square plus 2ab plus b square plus a minus b the whole square is a square minus 2ab plus b square, and the denominator remains as it is, which is 2 cos square theta. I can get rid of 2 sin theta and minus 2 sin theta, and what am I left with? I am left with 1 plus 1, which is a 2, and sin square theta plus sin square theta is 2 sin square theta. The denominator is 2 cos square theta. We can factor out a 2 from the numerator and it becomes 2 times 1 plus sin square theta, all of that divided by 2 cos square theta. Get rid of both the 2's and now I am left with 1 plus sin square theta over cos square theta. Now we can just split the denominator with both the terms in the numerator, so it becomes 1 over cos square theta plus sin square theta over cos square theta. 1 over cos square theta is sec square theta, and sin square theta plus cos upon cos square theta is just tan square theta, and that is what was required in the question. Fair enough. Next question. So this thing says prove that 1 plus tan square theta upon 1 plus sec theta, and that should be equal to sec theta. Okay, let us start. So we'll start with the LHS. LHS is equal to 1 plus tan square theta, the whole thing upon 1 plus sec theta. Okay, now I definitely know an identity which is sec square theta is 1 plus tan square theta. So sec square theta is 1 plus tan square theta, which means tan square theta is sec square theta minus 1. So I can write sec square theta minus 1 is equal to tan square theta. Now I may replace the numerator, that is the tan square theta, with sec square theta minus 1. So this thing over here becomes 1 plus sec square theta minus 1, all of that divided by 1 plus sec theta. Now the numerator is factorizable, difference of squares. Obviously this is not 1, it is a 1 square. So a square minus b square is a plus b times a minus b. So 1 plus sec theta plus 1 times sec theta minus 1, all of that divided by 1 plus sec theta. We can get rid of 1 plus sec theta from the numerator and the denominator, and I am left with 1 plus sec theta minus 1. Get rid of plus 1 and the minus 1, and you are left with sec theta, and that is what was required in the question. Very easy, and that is it. We don't have any more questions over here. Thank you so much for watching. Stay connected. Bye. So hello people and welcome back. In this session